climate change isn't uniform. Its impacts vary wildly by region, a complex dance of temperature, precipitation, ocean chemistry, and extreme events. Traditional models often struggle with this complexity. That's where data science steps in. We're drowning in data. Decades of satellite imagery tracking deforestation and glacier melt, thousands of weather stations, ocean buoys measuring acidity, species observation records, even soil moisture sensors. But raw data is overwhelming. This is where AI, especially machine learning, ML, becomes our essential lens. Think of it as a super-powered detective. Pattern recognition, ML algorithms devour this massive data buffet, uncovering hidden patterns humans might miss. They can detect subtle shifts in vegetation health, from satellite photos years before a forest collapses. Predictive power, trained on historical climate and ecological data. AI models forecast future impacts. What if scenarios? What happens to this alpine meadow if summer temps rise to degrees C? What if rainfall decreases 20% in the Amazon basin? AI runs these simulations at incredible speed. Understanding interactions, ecosystems are intricate webs. AI helps unravel how multiple stressors, like heat waves plus drought plus pests, combine to push a system over the edge. It models the cascading effects. Species-specific insights. Where will this endangered bird find suitable habitat in 2050? How will warming waters affect this crucial fish stock? AI models species distribution and vulnerability with remarkable precision. Let's make it concrete. Imagine this coastline. Data science integrates satellite data on current wetland extent, LiDAR scans for precise elevation, tide gauge records and climate model projections for sea level rise, sediment flow data from rivers. An AI model processes all this. The output, a high-resolution map predicting exactly which patches of marsh are most likely to drown by 2040, 2060, 2100. It identifies crucial areas for targeted restoration or protection now. Or consider a forest. AI can analyze tree species data. Some tolerate drought better. Soil moisture and groundwater levels from sensors. Historical climate data and future drought forecasts. Pest infestation patterns. The model pinpoint stands at highest risk of mortality in the next drought. This allows forest managers to prioritize thinning, fire breaks, or planting resilient species, making conservation proactive, not reactive. This isn't science fiction. It's happening. Coral reef early warning. AI analyzes sea surface temperature, acidity, and light data to predict bleaching events, giving managers time to reduce local stressors. Predicting permafrost thaw, crucial for Arctic ecosystems and global carbon release. Biodiversity hotspot protection, identifying areas where climate and land use change create the perfect storm for species loss. The power is immense, but so is the responsibility. We need more and better data, especially long-term ecological monitoring, transparency, understanding how AI models reach conclusions, explainable AI, collaboration, ecologists guiding data scientists, policymakers using the insights. Data science and AI don't offer a crystal ball, but they provide our clearest window into the future of our precious regional ecosystems under climate stress. They turn overwhelming complexity into actionable intelligence. By harnessing this power wisely, we can move from simply documenting loss to actively engineering resilience, giving nature its best fighting chance. The models are running. It's time to act on their predictions.